welcome to today's webinar. My name is Elise. I head up the growth team here at Yhat, and I'm joined today by our Rodeo product manager, Colin, that's him, and our co-founder and CTO, Senior Greg Lamb. If you aren't already familiar with our products, well, first of all, welcome. Big hello from Yhat, and I'm just going to give a quick overview before we dive into the demos. So we're going to start today with Rodeo. That is an integrated development environment, or IDE, for writing Python. It is free to download and use. If you haven't already grabbed it, there's a link down in the moderated chat below. And it's good for anyone who already knows how to do Python analysis, data scientists who use it in their work, or if you're just getting started with Python and you want to learn. So in a few moments, Colin will give a product tour of Rodeo and highlight some of the latest and greatest features we've just rolled out. After Colin wraps up, he's going to hand the mic over to Greg, and Greg will be giving a technical demo of our other product, ScienceOps. So if you're not already familiar, ScienceOps is enterprise software. It allows you to deploy data science models into production apps. It can be used for deploying either R or Python models, but today Greg will be working in Python, and he'll be deploying a deep learning image recognition model into a JavaScript web app. Other places you might know us from, if you haven't already checked them out, check out the Yhat blog, and also ggplot. We just released a new ggplot, and that's a package for plotting in Python, which you actually might get a sneak preview of today. Other than that, if you have any questions during the webinar, you can submit those to me. I'll be moderating at just the bottom of your screen, and we'll cover those at the end of the webinar. So with that, I will hand it over to Colin.
Thanks, Elise. Hey, everyone. My name is Colin. I head up the product team for Rodeo. And before we get started, I figured I'd give everyone a brief history of Rodeo, where it started, but more importantly, give you guys kind of some insights into where we're going over the next couple months. So with that, Rodeo was first released in April 2015. We iterated on that several times, but then in 2016, just last month, we released a full-fledged rewrite for Mac and Linux to basically deal with all the stability and issues around finding Python. So that's what we've been working on for quite some time now. But then the really exciting stuff coming up on the roadmap, we have better plotting functionality, so being able to enlarge plots, export them, and save them. Then in August, we have Rodeo 2.0, the rewrite for Windows, being released. If you're a Windows user now and are interested in beta access to the latest test version, let me know. You can also find it on GitHub. And then the other big features, will be adding more tutorials, which I'll show you in a second, and then pop-out plots and tabs for multi-screen use. And what that will look like is something like maybe work in an environment where they have dual monitors set up, or maybe even 3. And one of the major limitations of lots of editors to date is you can only work in one window at a time. So pop-out plots, as we're calling it for now, is basically the ability to take a plot or a data frame or an environment and drag it into its own separate window, so you can visualize multiple things concurrently and work in just generally a larger workspace. So if you're interested in that and want to weigh in, we have a discussion forum that you can actually get to from within Rodeo, and you can give us your thoughts there. We always look there for user feedback and ideas on new features. So with that, I'm going to jump into actually using Rodeo and show you guys some basic workflow and some of the base functionality that the product has right now. So here we go. This is the Rodeo UI. Note that the pig at the bottom is not part of the standard fare. You don't get a pig with your edition of Rodeo. It's part of Greg's demo. So anyway, I'll kind of briefly overview the panes and the layout of the IDE. So over here on the left is you have an editor. Similar to Atom or Sublime Text, we actually run Atom below the hood. But I can write code in here, define variables, and then to actually run the code, you'll note that we have a console down here on the bottom left. And then, so to move code from the top to the bottom, I can either run command return, or I can use the run line button. And what that's both going to do is pass the information from the editor down to the console. So if I say type X up here at the top, you'll also notice I get a nice doc string here showing us what the value of X is. But hitting command return, you'll see X being defined down here at the bottom. We also, on the right, I mentioned previously the tutorials. So all the tutorials that we have, if you're just getting started in Python, are over here in this panel. I can click in, and the Intro to Python one's available right here. The documentation, the discussion forum, as well as the GitHub repo are also all available in this sidebar as well. So with that, I'm going to actually do a little kind of brief data analyses on a data set that involves pigeons. So to do that, we'll first load in the American Racing Pigeon Union Incorporated logo. Just pulling that off of our blog. And then from there, I'm going to import ggplot. As Elise mentioned earlier, we just released a new version. So I'm going to highlight all this code, and same thing as previously, I'm going to hit command return, and that is going to run it. You'll see on the right here, we now just got a whole bunch of data frames available that ship with ggplot. So the pigeons plot here, we've got a whole bunch of data about the breeders, the names of the pigeons. Perch Potato here is our 4th place finisher, and then the speed at which they flew this race at. So we can look at a couple things here, starting with the distribution of the speeds. So this is effectively, of all the pigeons in our data set, what was the speed they completed the race at. And it's kind of interesting. You can see, just looking at this simple chart here, we have like a bimodal distribution. So who knows, maybe the wind picked up after the 1st place finishers got in and the other guys kind of struggled. Hard to say. But we can kind of also, again, get some summary stats down here, just running with basic pandas describe sort of functions. But let's say we wanted to split our pigeon set in half. So that trough here we see in the right falls right around 130. So we can split that in half. See what our distribution looks like if we split them down the middle like that in a nice little histogram. And now we're kind of set, given that we split the data up, we can also look and try to determine which of our breeders was the most effective pigeon breeder. And because breeders are allowed to submit more than one pigeon to a race, we can't actually just look at the position, because if I have a 1st place and a 100th place finisher versus a 5th and 6th place finisher, I might be a better pigeon breeder. So what we're going to do is do a log ranking, and you can see here, this is kind of the curve or the distribution that we're going to fit the position to. And then I'm going to apply that same sort of mapping to the position that each pigeon finished in, and then group and order by the breeder. So you can see here, if you guys were looking for a pigeon breeder to go race your pigeons or train your pigeons for you, Jerry Allensworth, the Texas Outlaws, they would be the guys you wanted to go talk to. So that kind of wraps up a quick overview of Rodeo. Would love to get your guys' feedback on the discussion forum, which you can access down here at the feedback button. But with that, I'm going to hand it over to Greg, and he's going to take you through a slightly more complicated deep learning model.
All right, thank you, Colin. So I'm going to jump back to our presentation just for a second here. So ScienceOps, as Elise mentioned earlier, it's our enterprise product for deploying and managing analytical or data science routines written in Python and R. We have customers using that software to do things like financial services, tasks such as fraud detection, credit scoring, that sort of thing. Marketing use cases, recommendation engines. It's really anything that any type of application that needs an analytical component, ScienceOps can work with. So for today, I'm actually going to be showing a kind of a fun example of creating an image tagger or an image recognition model using Python, and in this case, the Keras library. For those of you that aren't familiar with it, Keras is a deep learning library for Python. It can work with other popular packages like Google's TensorFlow or the Theano library. So for today, again, we're going to be making an image tagger, and then I've got a little application, a little web app that integrates with it that I'll show towards the end, and that'll give you just a little bit better of an idea for how it works. And then, of course, I'll send out the link at the end so you can play with it if you want to. Okay, so for our image recognition model, I'm going to jump back into Rodeo to do sort of the analytical part of my model. You can take a look here and see that the code that I'm using for the model comes from an academic paper that was published fairly recently about how to detect different objects from within images. It's based off of a large open source data set, and you can find all of the code and links and references and bibliography on our GitHub account. But to build the model, I'm going to import Keras, and I'm going to set up what's called a weights function and an actual model. So I'll load that into Python here. And then just to give you a quick preview of the types of images that I'm going to be categorizing today. Here's an example one of a pig. Pretty simple image, standard JPEG, nothing too special. And then the actual model that we're building, we're going to be categorizing each one of these images into one of the labels that we have right here. So you can see it's everything from a goldfish to a pickup truck or a house. It's a pretty long and extensive list. I won't go through it all here. But the general idea is that we want to be able to take in an arbitrary picture or image and try to figure out what is actually in that image. So to do that, we're using this. We're using Keras, where we have our model. The weights are, we've downloaded the weights from the academic paper that we're referencing here, and I can load my code in to Rodeo here, and what we're going to have is an SGD model that will be able to compute the best or the most similar images and try to find out from a new image that's passed to it what's actually in it. So in this example, we've got our pig, and if I run this code here, we'll see that when I print out my best guess, you can see that it thinks it's a hog or a pig or some similar name, maybe a brush kangaroo. That's not quite as common, at least here in the US. Okay, so I've got this model. Seems to be working pretty well on a test image. The next piece that I'm going to showcase is the actual ScienceOps bit. So that's how we take that model and get it off of my laptop here and into a production environment and deployed as an API endpoint. So what that means is we'll be able to send new data to my deployed model. That deployed model will tag and categorize that information and then send it back. So to do that, we're going to use the Yhat Python package. Load that in here. And then to specify the model that we're actually going to deploy, it's really easy. just extend the Yhat package and specify an execute function. And that execute function is going to define how new data is processed and how a prediction is made using that data. So for us, that means decoding an image, taking that image, running it through our model, and then returning some guesses or predicted values about what things we think are in that image. So to do that, I just pasted in the code that I showed you above into this function, and I'll run this class right here. One thing that I'll just note before going any further is that even though I'm using Rodeo, by no means are you restricted to using Rodeo when you're deploying a model to ScienceOps. ScienceOps can work with anything, whether it's IPython notebook or just a Python script that you run from the command line. It really doesn't matter to ScienceOps. I'm just using Rodeo because I like it, and also because we've been showcasing it in our demo today. All right, so I've got my Yhat model class. I've got my image classifier, my image detector. The next step is to actually deploy my model. So for us, what that deployment means is that when I run this deploy function here, what the Yhat package is going to do is it will inspect my Python environment. It'll bundle up any dependencies, any extra functions or modules that I've written, helper code, all of that. It's going to bundle it up and transfer it over to our ScienceOps server. Once it gets up to the ScienceOps server, it'll be deployed as an API endpoint, which I'll show you guys just momentarily. And as that API, we can, like I mentioned earlier, send new data points into it and get results back. So I'm going to jump back over to our ScienceOps setup. So you can see here that we have our ScienceOps server set up and running on one of our Yhat demo accounts. This one in particular is running on our AWS account. That said, we can run ScienceOps pretty much anywhere, whether it's on your own hardware or your own data center, on your own cloud provider such as Azure or AWS. Doesn't really matter to us, but for today, we're running here on AWS. So I'm going to log into my account here, and what you'll see here is that we've got a few options. I'm currently viewing my models, so that's all of the models that I've deployed to my account. And I'll jump down here to the image recognizer, which is the one that I just created. And the first bit that I'll just sort of go over is that, as I mentioned, we've transferred that model from my laptop up to the ScienceOps server, and that model is now available as an API endpoint. So that's online and ready to receive and make predictions on data in real time. That API endpoint is very, very simple and can work with just about any language, platform, framework, really whatever that you all are using is going to work with ScienceOps. We actually have some pre-populated code snippets down here just to show you how simple it is to integrate a model into another application. So to give you all a sense for what that might look like, I actually have a really simple application, web app prepared to show you what that looks like. So I'm going to jump over here quickly to our Yhat GitHub. If you want to check this out after the demo, please feel free. We have a photo tagger or image tagger application available on GitHub. It's a really simple app, and as I showed you earlier, it's just going to be able to take an image, send it to ScienceOps, get results back, and then it'll show you some tags or some labels for what it thinks is in that image. So this is just HTML and JavaScript, nothing too fancy. And with just a couple lines of code, I can actually integrate this with ScienceOps. So without further ado, I think we should just go ahead and test this out. So why don't I start with a pickup truck? So I've uploaded this pickup truck to my little application here. When I click tag, the app is taking this image, sending it over to ScienceOps. We're getting those results. Those are the exact same results that I got from my Rodeo session. So everything's been transferred over into my Yhat model, and I can ensure that everything's going to be the same as when I was running it locally. I'm going to try another one. Maybe I'll do again. Send it over, and there we go. We see the exact same results that we saw on my laptop. So feel free to go check this out. Everything's available on GitHub, and including the model as well. Okay, so apart from the API endpoint that ScienceOps provides, ScienceOps also includes some decision management and auditing features that make it easy to maintain your models over the course of their lifetime. So that includes things like being able to inspect and version different iterations of your model. So say, for instance, you have different variants of the image recognition model. When you deploy those to ScienceOps, they're each going to get tagged with their own metadata, things like when they were deployed, who deployed them. You'll be able to see the actual source code that goes into that model, all that good stuff. Apart from that, things like tracking logs, being able to see what your model's actually doing when it's online. Other things like just general administration, restarting a model, stopping a model, setting environment variables, all that good stuff. So apart from the model level, auditing and management, ScienceOps also provides information and visualizations around the input and tracking of the data that's being sent into your models. So, for example, you can filter out and inspect over different time periods how much data is getting sent in and out of my model, whether there are spikes in possible errors, all that kind of stuff. In addition to sort of those summary, generic summary metrics, you can also see the exact data points that are being sent in and then out of your model. So take, for instance, this credit risk model. You can see the JSON data that's being sent into the model, and then the credit risk score that's being captured and sent out of the model. In addition to just being able to see the raw data feed, you can also configure ScienceOps to track individual data points that you're sending in and out of your model. So say, for instance, in this case, I'm tracking two numerical and then one categorical data point. I can set that configuration up in ScienceOps. And then what will happen is that ScienceOps over time will track and monitor the distributions and the relationship of those data inputs and outputs and see how they're changing over time. So super handy for doing things like taking a quick look at your inputs and outputs, making sure there's not any funny values. So in this case, there's some values that say none. That might be something that's worth further investigation. You can also take a look at the distributions of the numerical variables that are included in a particular model. So if For instance, if you have a lot of values that are close to 0, that might be another thing you'd want to check out. All this data is also exportable. So if you're running a data warehouse, such as Redshift or Greenplum or Netezza at your company, you can export all of this into a data warehouse environment as well. Great. So with that, this will just sort of conclude my quick demo, but we're happy to take questions. It looks like we've got a few extra minutes. So if you have anything, please feel free to throw it into the chat window.
Thanks, Greg. I just actually had one come in. This is from Amy. She said, it looks like you were working in Python today. Can I also deploy in other languages to ScienceOps?
Yes, so ScienceOps supports both R and Python models. So the R deployments look almost the same as the Python deployment that I showcased today, and same goes as Python. You can run it. You can deploy from RStudio, from command line, really whatever it is you want to do. Nothing is tied to your workflow or IDE or anything like that.
Great, sounds good. And just had another one come in. This one is from Toby. Can we use custom packages in environments?
Yeah, so custom packages there's sort of two flavors. One flavor is R and Python packages that are on something like Cran or Conda or PyPy. All of those can be automatically detected and incorporated into a model. So in the case of my image recognition model, you can see that it automatically picked up the dependencies that of other libraries. And then in addition to that, you can also install your own custom code into ScienceOps as well. I won't showcase that just because that's a little bit more in the weeds, but just know that it is something that's an option.
All right, just had one come in from Israel. Can you talk a little bit about the unit testing feature?
Sure. So unit testing within ScienceOps is a great way to make sure that the models that your team is deploying aren't causing any errors. So what it allows you to do is upload sample data points onto ScienceOps, and then each time a model gets deployed, before it becomes the production endpoint, we'll run these unit tests or run these example data points through the model, make sure there aren't any problems or any errors. Assuming everything's okay, then we'll swap that model in for the production endpoint. So it's a great way to just have like a final check to make sure that your team isn't deploying anything to production that could break other processes or other teams' work.
Awesome. And we've got another one. This one came in from Ryan. How does the export from ScienceOps work? And he asked, is it a flat file, API, another connection type?
Sure. So the export is done through an API. Our APIs all use a very, very simple JSON format, and that's very configurable. So if you needed it to match a particular format, that's something that you could set up from within ScienceOps.
Sounds good. All right, it looks like that is all of the questions we have. We'll stay on the line for a couple more minutes in case anybody has any. Otherwise, thank you very much for joining us. Hope you enjoyed the demo of Rodeo and ScienceOps, and we'll look forward to hearing from you guys again. Oh, and one last question. I keep getting, will there be a video posted? Yes, there will. It'll be on YouTube, and I'll also send out a link for anyone who registered. So thanks for those follow-ups.